Design of light gauge steel frame for building structures with FrameCAD Structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
In this section, we shall learn the creation of joist and the process of doing that. And before that, we'll go back to the ground floor layout. Now see, if you go to the 3D, we'll see the top of the beam is actually matching with the top of the joint, but to have the deck profile supported on the beam, it should actually, the top of the beam should actually match with the top of the joist. Now earlier we have decided we'll keep a joist depth of 350. Now this joist depth actually, before deciding the joist depth, we should actually make a panel having greater span and test a joist whether it is passing or not. So this has been already tested with 1.15 mm thick the joist passes, but we'll start with joist with 0.95 mm thick stud. Now let us go back to the layout. In the layout, we'll correct the elevation height of top, reduce level of the top level of this beam. So list this beam, Milai command, select this beam, and this beam. So the beam top RL should be 3050 plus 350, that is 3400 mm. 3400 mm. Now accordingly, the wall below this beam, the height should be also amended. So let us take the list command, list item command, select the wall height. Now height of this wall should be 3400, that is bottom of the slab, minus 266, that is depth of the beam, so 3134 mm. This is what has been shown in this drawing. Now this wall, if you look at this wall is 1384, but and a joist has been considered. Here we can put a image beam or joist. So instead of putting a joist, we can take a wall to the top so that the slab can be rested over here. So if I take the DLI dimension of this from the top of the landing slab to the bottom of the slab, this works out to be 1750. So we set the height of these two walls, LI, this wall and this wall, as 1750. So let us check. Our lower wall is 1384 plus 266 plus 100 mm slab plus 1750. So works out to be 3500, what it should have been. 3400. It should be up to the bottom of the slab. So let us measure the distance again, DLI command, from this point to the bottom of the slab. DLI. This is the slab top to the bottom of RCC. This is 1650. So our wall height should be LI 1650. So now if we calculate all these distances, the lower is 1384, the main landing beam is 266 mm in depth, and then landing slab is 100 mm, then 1650, this is 3400. So bottom of the slab, first floor slab level is at 3400. So let us check with panel P3D again, P3D again. Now it is not coming at bottom of the slab. So let us find what is the reason. We should have actually listed this and change the top level height of this beam as 1650 and 1650. I mean, go to model P3D again. Now the top of the beam is okay. So see, there is a gap that could be seen at the land level. This gap is actually denoting the 100 mm thick slab. So we are all set to generate the joist layout. To do that, you have to draw few rectangles. So and some lines. So let us make a layer for rectangular for joist. New layer, rec for J joist. Rename joist. Let us make this color pink. Set its current layer. Let us make a rectangle here. Rec. This joist was off, so let us make it 1 and then make a rectangle. Rec. Color doesn't match, so let us see what is the color. It is color number 6, so let us take command color 6. Okay, so now our object will be drawn with this color. So first we draw a rectangle here. Before drawing rectangle, we need corner points. So let us draw some lines, orthogonal lines. Line here, line here. So let us have the first rectangle, REC rec. Then let us have second rectangle, REC rec. need a line here. Right. We need a rectangle here as well. See it. We'll need a rectangle here as well. So let us have this start line to look at the point. See, right? Then we need a central line from here. X, extend this line. X, enter. Has been drawn as a rectangle, so we have to take a line. Now X. Let's trim this line here. Trim this line. Let us draw a line here. We will need a line here. Right. Now we draw some line here so that I can take the reference point. LEL line command from the reference point here and from the reference point here. Now we will take this rectangle to the third border. So let us draw a line here. Here. So let us isolate these lines, lay ISO, copy, this is the base point. Enter. This has been copied. We can delete this line. This is no more required now. We can delete this rectangle as well. This is no more required now. So now let us go to lay on ISO command. This is where our joists are to be drawn. Now we need to find the center line of this because joist will be supported here. Center line, draw a perpendicular line, center line, draw a perpendicular. draw the perpendicular. Create this line. Now we'll draw some closed polygon. So these polygons are required for joist, for drawing this joist. So let us make another layer, new layer, joist poly. Let us make color blue. Okay. This is also blue. Color number 5. Set the color. Color as 5. First of all, let us draw a rectangle here. Enter. Then we will draw a polyline. We have actually, let us trim this line here, wander here. This is our staircase opening. This part is our staircase opening. So let us draw a polyline here. This goes like this, then like this, then like this, then like this, then here, then here, then here, then here. Then here, then here, then here. We should have set the color, current line color is blue, CUL color in the command line color.
बोला तो पापा को सुनते तो नहीं। अरे अपने पास नहीं किया उसे।
To make this
Shit, no.
joist poly as the current line. So we have drawn joist poly as the current layer. Match this line as the properties of this line. The rectangle drawn. So it has been matched. To draw the second polyline, closed polyline, TL enter. Let us start from here. TL enter. Start from here. Then come here. Start from here. Come here. This point. This point. This point. This point. This point. Point. This point. This point. This point. And this point. Again here. Let us start from this point. TL enter. Start from this point. This point. This point. This point. This point. And this point. Enter. Let us start from this point. This point, this point, this point, this point, this point, and this point. Enter. Now let us draw two rectangles like this. This point, and this point, and then another rectangle starting from this point and ending at this point. No, we do not need this line anymore. So let us isolate the initial layer of rectangles and lines. Lay ISO. Select this line. Lay ISO. Select this line. Enter. Can be seen now. Now again go to the commander, lay on ISO. So our polyline for creating the joist are set. Now before creating the joist, you have to set the joist properties. For command for that is joist setting command is jset. Jset type jset command bar jset enter press enter. So this is already set from a previous project. So see the joist type is 89 section with 90.95 thick, side wearer is 89 section, end wearer is 89. We do not need any interior wear. Member height override, that means the joist depth of the joist will be 350. The joist space is 610. Interior wear is 610. We do not need any ceiling button, so we have kept it 0. Ceiling spacing. Reduce level 3400, that is top of the joist. Wearer method is blocking. We have another wearer method, but wearer underline, wearer inline, alternate blocking. But blocking is preferred. Interior wearer method is also blocking. Double interior, let us keep it true. Walls, then layout color. Then come to the applied load. So dead load, our dead load was 0.31. 3.1. Live load, except for the corridor part, staircase plus the live load will be 2 all the FrameCAD joist wherever it is coming, the live load is with 2. Ceiling load is 0.3. So what to get at the dead load is 3.4, or we had calculated in the Excel sheet. Design point load, let us keep it like this. Reflection limit, whatever is default, let us keep it in the same way. So same. Now to draw the joist, the command is JD. Select the polyline, closed polygon for which the joist are to be drawn. So this is the polygon we have drawn. Select the first point and then select the direction of the joist. It should be orthogonal. So the joist has been created. Now see, this is a symmetrical building. We do not want the joist to be unsymmetrically placed. So what will you do? We'll just delete a set of joist. And the blocking also. Now we shall mirror all these joists. Command is mi, mirror, select all the joists, then select the blockings. enter. From midpoint, drop a perpendicular PER bar, enter, enter. Now we really do not require this side mirror here because we have image view mirror. Image view mirror, we should stretch this blocking perpendicular to PER bar. Again, we do not need this, so we stretch this by grid points to the edge of the steel frame. We do not need this one. We do not need this one. Instead, we'll try to copy and see if it fits here. Yes, it is. It does fit here. Then again, let us copy this both of this into. Select the base point and paste it here. We have to add a joist at the middle, so command for that is add joist, key post joist, joists WJ935 joist, it shall be joist. Creation method is point by point. Create, let us take the midpoint and then drop it perpendicular PER bar, or you can select midpoint also. Midpoint, click once, then click twice. So the joist has been formed on the sideway because of the mouse click. It is detection with the software is very less. So let us move this joist by 59 divided by 2, 59 divided by 2, 44.5. After picking the base point, type 44.5 on the command bar, then after giving the direction, that should be orthogonal. So the joist is placed at the center. Now let us match the properties of the joist J4 with joist J3. Now we shall draw. For this panel we shall draw joist manually. So add joist, create point to point, take this center point, maybe mid, drop a perpendicular PER bar, on click to click. Now this joist has been again not placed properly, so let us move it. So let us copy this joist at other places. Taking base point, let us copy one of these joists here. Copy another joist here. Now these two joists on the sides are actually side mirror joists, so let us list them. Li, side bearer S2 level S2 amend. So we need the blocking here as well. So let us select those blocking, copy those blocking, copy all these blocking, hold a base point, copy all those blocking, hold a base point and paste it here. For the other part, we have to draw joist manually. So let us copy one of these joists, hold the base point, holding the grip point, let us move it perpendicularly. And let us copy the same joist again. Now we can copy this end joist. CO copy. This as the base point. Place it here and place it. So then we have to put a end block at the side as well. Let us take this here. Now click on it, hold the grip point, move it perpendicularly, PER part, enter. Does not move. PER part. Copy this, we copy. See, the end block here seems to be named as same, but when we level it again, the software will automatically label the different blockings with different names. That can be done at a later stage. So two of this part is complete. Now our third part, we have a rectangle closed polygon here, this point, JD, enter, select that polygon, select the start point, give the direction. Now this end bearer we do not need. Also we do not need this side bearer. So we can stretch this perpendicular. Now here we can copy one of the end block. Take this as reference point, copy this block. So this has been copied. Next, we can either mirror it or create joist. So we shall mirror it. Mirror is the command. So let us select all the joist, then end blocking as well. Go to the midpoint, control the midpoint, place enter. This is not created properly. This has been not created properly. There could be some possibility error in holding the midpoint. So let us undo it. Control Z. So let us draw a line here. Now let us try a mirror command. Enter. Maybe midpoint. Perpendicular to the border. Okay. Now it has been drawn properly. Now let us draw a joist for this part. Again ZD, select this polygon, rectangle, give direction, enter. So we do not need this end plate and blocks. So we need to delete it. Now this joist has not been created properly. There seems to be alignment problem, so let us delete them and create it again. JD, select the polygon, take it, give the direction, enter. Now this has been properly. So at this place, this joist will be placed over the wall, top of the wall, so this joist would be required. So we do not need these blocks here. One set of blocks is already there as a separator between the joists. So let us copy. Let us mirror all these joists. Mirror is the command. MI, select the joist, then another joist, then joist, then the end mirrors. Enter, go to midpoint, drop a perpendicular to the border, enter. Now we have to change the property of this joist also. So let us match the properties of this joist with this. Now let us go to the 3D view and see if the joist has been properly created or not. So create 3D view of the joist. The command is J3D. You can see the joist has been properly created, but the issue is that this joist and this joist is actually entering inside this column. This end blocking is also entering in this column. To come over this problem, we should copy all the columns here. Now before we copy it, we should set their top level properly. So top level of this column is 3400. However, top level of this column is DLI. Let us measure it from the BLI, enter. This is 5066. For this column, BLI, enter. Now if you take a line here for all practical purposes, for LGS modeling, you do not need to set the bottom of this image beam. So let us take BLI from here. So for this column it is 6150. And but it doesn't seems to be the top. So BLI for this column, BLI is 6550, and this will also have the same BLI. So let us go to model layout. We have this column at 5066, these two column. So let us list these two columns as LI, LI, 5066. Keep. For these two column, LI is 3400. Listing top level is 3400. And this for this four column, the top level is 6550. List these items. LI command, then select these items. List them. Now post overall height is 6500 already has been taken. So this is our 6550. LI. Let us go to 3D model, P3D and P3D, enter again. So our columns are properly set. Now let us level all these joists. L is the command. JL is the command. Earlier LA was also working. So let us select all the joist. Enter. Let us from 1, enter. So all this joist has been leveled. There is 1 E2 missing here. Copy. You can copy it from here. 1 blocking missing. And paste it here. Again we can copy 1 joist from here. Paste it here. If we list this joist, let's see what happens. See now material information is also there. It's LE, LE, LE. LE means when these sections are placed like this with wave parallel to the ground level, then it is called LE section. And when the waves are placed in this way, this is called LC section. So while listing this, we'll get a parameter called wave spacing. So let us set wave spacing of all these joists as same. Select a joist and select all the joists. Enter. So material information we shall give this wave spacing. So let us make the wave spacing 350 so that the diagonals are around about 45 degree. So this has been set. So with this our preparation of joist is completed. Generation of joist is common for detailing part for the wall panel and joist. There are other things to be done, but before that we have to draw each and every part so that there is no confusion by the software while we level each level. Because if you keep on detailing floor by floor at each time, the software keeps on listing one item from a same floor to the other item. Yes, one thing is left. We need to copy this post. So you copy this post to joist border showing the joist level and the joist. Enter. The point of reference point at the base point and paste it here. We can copy the beams as well. Let us copy them as well. So you copy this beam copy this beam, CO copy, on the command bar, CO copy this beam, this beam, this beam, this beam, this beam, this beam, enter, select the base point, paste it here. So we really do not need this to be shown here, this beam and this beam, because there is a joist over it. Now why did I copy this? So we shall try to use a property. We do not need to show this beam as well. So we'll try to cut this member. So MC, select the member to cut, select the member and then cut it here, enter. So select this member, this has been cut. Then MC, select this member, select the cutting point, MC, then select the cutting point, enter. So delete this member. Now select this member, MC again, member cut, select the side mirror, select here, select here, enter. So delete the extra portion. Again MC, enter. This point, this point, enter. Now let us go to the 3D view again, J3D again. Now if you see, the joists are not entering the column, they are construct. So when we issue the command to detail the joist, it will be detailed in AutoCAD file accordingly. View, 3D view, free orbit. Let us have a look. Everything seems good in the model. So in next section, we'll generate the wall at the first floor. We really do not require to generate the wall at the first floor. We can copy this walls of the first floor and list them and reduce the number of studs and make some walls load bearing and some wall bearing depending on the truss span. So there are at places there are some walls which are not there at first floor level. So we'll have a clear span of around 8 meter truss there. So we have to change all these things when we model the walls LGFS wall panel at the first floor. Before exiting, file, save. So qsave command will come in the command line. Then we can close the FrameCAD file.